Hello, good Monday evening. We're going to land Timber Stream. We're going to do a little QoS labbing here, at least one. Low latency queuing, day 422. Still going strong here. Today, yeah, it was interesting. Not too much to report on the CCIE front. Just did take some Azure training today. It was interesting about Site Recovery Manager. So many products in Azure these days. And I will have some, who knows, I might vlog about that a little bit going forward. Another cool product with, of course, a very natural fit for Azure, right? You need to store, replicate things off site. What better place than in the cloud, right? And I am having some sort of Fusion Drive issue. Don't know what I'm going to do yet with this Mac. And basically the Fusion Drive on the Mac is they give you like a 256 gig flash drive, I think is what I bought it with, and then like a terabyte traditional drive. I keep getting these pop-ups about low memory, and I think that the swapping on the Fusion Drive is off. And I used to just leave that up to Mac, right, to figure out, but I don't know. Maybe something's going on. Might be looking at a rebuild here soon, but keep apprised of that. I'll try to do it in such a way that it impacts the stream. It would have to be like on a weekend or something. I've done this before, and it's on a Mac. It's with even with the free backup software that you get with the Mac. It's relatively easy to do. So we'll probably be working on that coming next weekend. But yeah, we got a lab coming up here, QOS LLQ, low latency queuing, and remaining bandwidth reservations. I've already done this lab, but I want to see how well I can do on my own again, without really looking at the lab key so much, maybe just at the end. So this was really interesting. It struck me when I first saw this lab. And I've got a paraphrase here. By the way, this is not my lab. This is from the INE workbook, which if you'd like to try out yourself, definitely check out INE.com. And you can buy the workbook separately from any other packages if you'd like to do it that way. And see the answer key and see all the other information and the explanations and screenshots and everything else, right? I don't show that on screen. I just sort of paraphrase some of the requirements here, and I work on it on my own. So anyway, we're going to basically be configuring router 4. And we're interested in this router 4 to router 5 link. It's interesting, you've watched the verbs on this, can give you a clue, right? Shape, obviously. Let me see if we close that down without... For instance, not sure what's happening to my voice either today. It's strange. Okay, we're in good shape. So this is the next lab coming up too that has to do with RED, which is random early detection. So we'll save that though, and let me just see if I can get this one done. I have some meal prep to do, some keto meal prep to do before Betty Bye tonight, so I may have to just do this lab here on stream. But let's see how we do. So shape, and I'm going to try to do it all here in Notepad first. Let's see, shape R4 to R5, 1 megabits per second. So that's going to be a parent policy because we're talking about a sub interface here. So we're just going to say policy map. Policy parent. GI45 parent. And we're going to do default class shape average 1500000. And then we're going to do a service policy. And this will be the child policy here. So the child policy is, first, let's do our classification. So we're going to do class map class HP v146. Been doing this a lot, and pretty much all these labs have been using the same class. And so it's going to be actually access list, IP access list extended, ACL HP v146, permit, TCP 151.146.0 equals www any. And the reason this is, and this is explained in the workbook. At first I was like, what in the heck? This is something squirrely, but there was an explanation. It's just an interesting use case, I guess. This is looking for all like 80 return traffic. So not traffic from the clients to port 80, but for some reason we're just trying to put policy on return traffic from the web servers on this network back to the clients. So that's why it is permit TCP, this range, source port equals www, destination, any. And then, okay, we don't need any access list to identify the next class. So let's do our class map, class match, access, group, name, ACL, HP, v146. And what we want to do here is, this will have remaining bandwidth. So this is going to be, we need to calculate our bandwidth first. So I think we need to go back to the voice. So IP access list extended ACL voice. Now I did on here match protocol RTP, but I remember in the lab explanation it said that RTP may not identify all voice traffic. Amazingly enough, that's in bar. So it recommended doing permit UDP any range 12678. Was that it? Let's see. It was something like 32768 divided by 2. Something like this range of UDP ports. And I'm assuming that is source. Permit UDP any range any. Okay, we'll try that. What I would have done is match protocol RTP, real-time protocol. But they're saying that's voice. And let's figure out the voice first. Because in our priority queue, we can have several flows and we can set guarantees on different classes, classes. But when dealing with remaining percent, it's going to be remaining from this one voice call. One VoIP call should have priority, be in the priority queue. So how much is a voice call? It says 50 packets per second. So in 1 second, 50 packets times 60 bytes. Although it says here layer 3 sizes. Now what we did before with class-based weighted fair queuing is we would measure the byte size based on the layer 3 size. This clue is saying this is layer 3, but the priority queue takes it. Hey, we have a sub. Colonel Panic, thank you so much for that sub. Awesome. Thank you for that Prime subscription. Supporting the stream. Thank you very much. Enjoy your emotes, your good bit emotes. And thanks so much for hanging out in the stream. Hope you enjoy the QOS goodness. Thank you very, very, very much. Yeah, so the catch here, and this is sneaky, right? Leave it to I need to be a little sneaky. It's saying VoIP calls assume that there are 50 packets per second, and the layer 3 size is 60 bytes. Well, guess what? Priority queue is measured when you do a bandwidth guarantee. It is done in terms of the layer 2 size. So we're getting really specific here, right? So if you do 50 packets of 60 bytes in size, 3,000, I could have done that in my head. I don't know how to use a calculator. Thank you for allowing us on your journey. You're very, very welcome, Colonel Panic. Thank you for taking the time to hang out and interact with the channel. I love it. So yeah, if we say 60 bytes, we know that layer 2 header will be 18 bytes additional, right? Usually 14, but we're using we know here in this case that we have a VLAN tag. So it's really 78 bytes. 50 packets per second, 78 bytes in size, 3,900 bytes. How many bits is that? Times 8 bits. Okay, 31,200 bits per second. So with the priority queue, when we specify the priority queue, we do kilobits per second. And we're just going to round one up. We don't want to do short of 31,200 kilobits per second. So we need to go 32 kilobits per second. So it will be priority 32. So let's set up this class here. And you really want to do this in the order, sort of in the priority order, so to speak. So we're going to set up our class map for class voice match access group name. And we're going to do priority 32. That's going to be 32 kilobits per second. Okay, so then in our requirements, so we want to do LLQ for at least one VoIP call. Additional calls can be made if there's no congestion. In other words, we're not going to reserve any bandwidth here. Read no bandwidth reservation for you. This needs to be reserved, and this needs to be reserved. So all we have to do is set up this class, priority, and this threw me off too because with class-based weighted fair queuing, CBWFQ, if you're going to define bandwidth reservations, normal bandwidth reservations, they all have to be the same. Like if you're doing either you're explicitly specifying the amount, like 32 kilobits, or you do percent. You can't do either or. With a priority queue, though, it's a single queue with multiple classes inside of that queue. You can mix them up. So you can say here 32, but here I can do priority remaining percent 33. Same for class map. We're going to call it scavenger. We'll say we don't need access list. Class map, class scavenger. Match IP precedence 0. Priority remaining percent 33. So essentially we are going to have, even though we have 3 classes, well, 4, because there's always a class default, right? If you don't fit in any of these classes, you're in class default. So we have 4 classes, but we're only going to have 2 queues. And one is the priority queue, and the other queue will be class default traffic. And it will use WFQ by default. It's something else I learned. Class default, if you have any other bandwidth settings, well, in that class, I'm not sure. Let's see. It might be FIFO. No, I think it's WFQ by default. We'll find out. So these are our classes, and now we need to do our policy map. And what do we call the other one? Gigabit 45, router 45, child. And we'll say class. Oh, I have these in the wrong place. This is something else I'm doing habitually. I need to change. The class map is only to classify. No actions are taken, right? So we're going to do class voice, priority 32. Class HP v146. Priority remaining percent 33. I think I have that syntax right. Priority remaining percent 33. Yep. And then we come to this, and we say service policy. No input or output here. This is another flashcard I made because I kept making that mistake. The child to the parent is you just specify service policy. Policy GI45 child. At the interface level, though, interface GI0 145, you do service. Oh, we have to do our shaping. It's right there. So service policy output policy GI45 parent. Okay, let's see how we do on the actual router, which I already have up and running in Azure today. We're in Azure today. I get a little bit of the heebie-jeebies about the what's going on with this computer, so oh, I'm gonna have to rely on the copy paste. Oh, we don't have copy paste madness today. All right, let's see if this works. Did, yay. And now put the class maps in, see if that works. Oh yeah, we gotta take this out. Man, if I get this right the first time, this is gonna be awesome. First copy paste attempt coming right up. IP access list. Okay, copy, paste. Hey, that worked. Awesome. Now we're going to do our policy map. Oh, the remaining percent isn't right. Okay, so let's check it out. Class priority percent. Remaining percent. So maybe I have to do, let me go back and look, 33 of the remaining. That's fine because that's percent. How much is this using, by the way? 50, let's see. 32 kilobits out of 1.5. It's not much. Wait, 32. It's like 2% of the bandwidth. I feel like we're missing something here. Reserve 33% of the remaining bandwidth. Kernel panic is my understanding you can only configure one priority. That is correct. You can only configure one priority queue, but you can have multiple classes in a single priority queue. I could be wrong. The others would be with priority. Bandwidth remaining. Hey, TCP dumping. Kernel panic, the others would be with priority. Yeah, you know what? I'm looking back here, and it doesn't necessarily say that. Yeah, it's only saying that it doesn't say that these have to be prioritized. So I think that's just bandwidth remaining percent. Maybe I misread something the other day. Let's see. What levels? I think you can have 1 and 2. With levels, yes. Maybe that's it. Ah, it did not copy. Copy. Death by hyphen here. Okay, policy. Let's stop copy and paste it. Hi, what system is this? Hey, Viable Clan member. This is a Cisco router image. Class voice. Priority 32. Class bandwidth remaining space percent. Okay. All right, let me just for grins. We didn't get it right the first time, but you know, not part of it we did. Okay, there we go. Okay, now we do our shaping. Copy paste hell. Parent default class default. Yep, got that one wrong. Shape average and service policy output. Nope, don't put that here. Service policy child interface jazz 0145 service policy output parent. Booyah. Show policy map Okay, class default. Here we have our shape. And class voice. Priority 32 kilobits per second. And bandwidth remaining percent 33, bandwidth remaining 33. And then class default. There we go. Okay, so now we're going to take a look at the workbook answer key. Oh, that's the that's tomorrow, or the next lab, I should say. Let me go to this lab, log in again. It logged me out for some reason. And it's going to make me go all the way back here. That's some good QOS. Hey, man. Yeah, it's looking pretty good here. And I almost configured it. Well, I didn't get the key part correct, but I'm getting where I can kind of do it on paper now, you know, which is good. I'm definitely making some progress. Valuable Client Manager, do you have Cisco routers running in the wild right now? These are running in Azure, so they're not real routers. They're virtual routers, and they're running in the cloud on a virtual machine in the cloud. In fact, I think it's set up. Yeah, this has my basically my setup here. CSR 1000V. No, these are viral images. So this is iOS V. Yeah, I should add that to my. Yeah, so this is hardware, software. I'm using EvenG Community Edition in the cloud. Yeah, that would be a good command. I want to make a note of that. to make a new command. 1 second before I forget about that. That on my to-dos. I need to do, you know what I should do? We've been playing with bots in Azure. It's real easy to set up like a Q&A bot and embed that into your, like your intranet site or wherever. Let's see, stream command regarding, I need a nightbot. Yeah, nightbot command for. Question, so 30 kilobit for voice, is that for PCMA? That's per leg, then don't forget throughway calls would be more, plus you need 1 kilobits for the SIP part of it. It was, actually what it said is that these are using the G729 codec. And that's all the detail it gave me. It said it's basically giving me a hint. It's saying, assume that the traffic is going to generate 50 packets per second. And the layer 3 size will be 60 bytes. So that's all the information. That's what the requirement I was asked to conform to. And in terms of the ports, I did get those correct. And I don't fully get, well, this should be 6.7. Let's see. Oh, I have no idea which annex number. This isn't really. I don't think we have to go that in depth with voice here on in the routing and switching exam stuff, but the main point is basically they're trying to give me the size to use. There was an explanation in the workbook about why, about the voice. And I'm trying to find that, but oh, there's actually a section at the bottom of the workbook here titled Further Learning, Computing Voice Bandwidth. That's kind of cool. I may actually, I just got to the bottom, like the last like screenshot, and I thought, oh, okay, that's it, I'm done. And I kept on scrolling, and I noticed further reading, and it has computing voice bandwidth. It's kind of extra credit, so I may check that out. Yeah, it says multiple classes inside a single policy map can use the priority keyword. So I can put here, for example, let's see, do show class map. Show class map. So 50 packets per second. Here's how the calculation came about, right? And this was a little sneaky. So 50 packets in a second. And it is saying they are 60 bytes in size. That'd be 3,000 bytes. But I don't know, man. That's way more voice than I'm familiar with. It's saying the layer 3 size is 60 bytes. Each packet is 60 bytes. You got 50 of those in 1 second. But with the priority, with the low latency queue, it measures bytes in terms of layer 2 size. So this is Ethernet. We have to assume that it'd be 50 packets per second at 76 bytes in size. You have to add the extra, or 78. You have to add the extra bytes used by the Ethernet header. So it'd be 50 times 78 times 8 bits, 31,200 bits per second. Or 32K, just to not leave out the 200 bits, right? That's how I came to that. And the workbook, I think, is agreeing with me. It is. Already 32. But what I can do, I can say class map, class, policy map, do show policy. So this is what I was talking about before. I can go into policy map, policy GI45, child, class, HP v146. And I can do priority here also. But I cannot use remaining percent. I can only put a percent, and that will use, but yeah, multiple classes inside a single policy map can use a priority keyword, but only a single priority queue exists. This is useful to ensure that one priority flow does not starve another priority flow. If you had voice and video, for example. So we could put, if we had video, we could say priority 128, right? Assuming like a video stream. Yeah, 32 kilobits per second, 78 bytes times 50 packets per second times 8. Oh, I wanted to see, show interface, let's see, show policy map. So class default, it says queuing here. Show interface J0 145. It's down. Show interface J0 145. Notice here, queuing strategy, class-based queuing. Input queue, queuing strategy, output queue. I'm trying to find where it shows, let's see. Let's see, show policy. Let's see that again. Show policy map. Priority, 32. Burst size. Bandwidth remaining, 33%. Queue limit is 64. And then we have class default. Okay. Very good. I think that's going to wrap it up for me, folks, for tonight. That was a good lab. I think we're going to check this one off after I read this computing voice bandwidth. It says it's normally necessary to do this when you provision LOQ based on the number of calls and the VoIP codec that you're using. So yeah, if you want to do a priority queue based on number of calls, you're going to need to figure out how much bandwidth that's going to be, right? So good stuff. Well, thanks so much for hanging out, folks. I hope you enjoyed it. Monday. It's Monday, so hopefully you've got a strategy for this week. I'm trying to get my strategy together as well. I think that I have, and let me go show you what I have left in this tiny workbook. So I'm checking this one off. And that means I will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 left. If I could do one at night, 2, 3, Thursday, then we got the weekend, and then next. Yeah, I'll probably try to target finishing this in 2 weeks. finishing QOS. I've been on it for about 6 weeks. And I made a bunch of flashcards that have really been helping me out with QOS. So starting to get a handle on it. Thanks so much for hanging out, folks. We'll leave it there. And we should, you can follow me here on Twitter. Well, here on Twitch, on Twitter, Instagram, and of course YouTube. And we'll see everyone back here new to the stream. Do you have a target sit-by date? Thanks for asking, TCP Dumping. Right now, I'm shooting for the fall. So I don't have a date yet. I've actually gone to the site to schedule it. And you can only schedule, I don't know if this is always the case, but you can only schedule for your lab like 3 months out. Like they only have dates reserved. So once the summer is over, my plan overall was to finish QoS in March. But this is looking more like the end of April, May. So security May, system management June, IP services July. And then that would give me a couple of months to do foundations, troubleshooting, and also, what did I say, July? Yeah. And then possibly some Cisco expert training, like Cisco 360 stuff. That's going to put me well at the end of the summer, making a trip in August. So probably November. I definitely want to do it before the end of the year, no matter what. Doing it by the end of the year, whether I finish this workbook or not. But I would really like to do maybe before the holidays, like in mid-November. It's kind of what I'm between September and November. Thank you for asking, TCP Dumping. That is the goal. So that will be about what day? Let's see. We're on day 422. So April, May, June, July, August, September, October, November. That's 7 months away. So that's about another 200 days out. But yeah, that's hopefully this next couple weeks, in 2 weeks, we'll wrap up the QoS section. And we'll be able to go on to security. The most exciting section of the CCIE routing and switching, and I say that facetiously. Anyway, thanks for hanging out, folks. Got to get that number, Big Abe, for sure. Hopefully this year. Hopefully this year, if not next, for sure. Hell or high water. Thanks so much for hanging out, folks. Appreciate all the support in the chat and the feedback and the guidance and tidbits. And I'm here 7 p.m. Eastern every night, at least Monday through Thursday. And it varies on the weekends. So we'll see you back here soon, tomorrow night, here in the Land Tamer stream. Y'all have a great night and rest of your week.